I showed you how to make a bloom and glow shader, the first thing that I want to do is show you the idea behind how the shader works. And the way that we're going to do that is I have this image in Photoshop, and I'm going to show you how to create bloom in just a 2D image in Photoshop first so that you can see how the technique works. And then we'll jump into the game engines and I'll show you how to do it there. So I just have this image of some cherries, it's just a sample image. And what I want to do is create some bloom here. And so the first thing that I'm going to do is clone the image so that I have one image on top of another so that I have a copy. Then I'm going to set the blend mode of the top image to linear dodge or add. And that just makes the whole scene quite a bit brighter. The next thing that I'm going to do is adjust the levels of the image to get rid of, actually, I'm going to hide the bottom image so we're just looking at the top image without adding the two together. Now let's adjust the levels so that we only see the bright pixels. I'm going to grab the levels handle that's all the way over on the left and pull it to the right till it's about halfway in between. So what I've done here is gotten rid of all of the pixels that are darker than 0.5 or halfway. So we've clipped the image so it's all black except for the brightest pixels. So I'm going to go ahead and hit OK there. And then the next thing that I want to do is blur this. So I'm going to go filter, blur, Gaussian blur. And you don't have to follow along exactly with these steps in Photoshop. What I want to do is just show you the idea behind it. Okay, so if I apply this blur, you can see that I've gotten rid of all of the fine details and we can just see like the kind of the blurry looking highlights of the object. Now, if I take this top layer that has been filtered, blurred, and adjusted, and I add it to my image, the result is bloom. So I'll turn it off. You can see that now I get the specular highlights and the bright parts of the image with no bloom. When I turn it back on, now I'm getting my highlights that are just kind of popping and glowing. So this is what we want to do in our shader. We want to take our original image, darken it a little bit, and blur it, and then add it back on top of our original image again, so that the areas of the image that are bright kind of bleed out and, well, they bloom. So let's switch over to Unity and I'll show you how to do it there. All right, so here we are in Unity, and the first thing that I want to do is save myself some time. We're going to be doing a lot of samples of the screen buffer, and so I want to create a subgraph that is a shortcut for doing that. And so I'm going to come up here to shader graph and pick subgraph, and we're going to call this sample screen. And then we'll open up our sample screen subgraph and get started. The first thing that we need to do is sample the screen color. And so I'm going to grab an HD scene color node. I want to make sure that I click this exposure box. And we're going to pass this out. But first we need to change our output. So let's open our graph inspector here. We'll set it to vector 3. And our output is the scene color. So I'm just going to set this to color. And we want to sample our scene color using our screen position. So let's add a screen position node. Now, if I want to, I can just use the default screen position that's here, and that will work fine. But in this case, I'm going to be altering the screen position, and so I want to have it independent so it's ready to add some nodes in between. So I'm just going to go ahead and save this as it is. And then I'm going to create a new shader that uses this subgraph. I'll right click and pick Create Shader Graph HDRP Full Screen Shader Graph. And we're going to call this Test Full Screen Bloom. And let's open it up. And now we need to add our sample screen subgraph to our Test Full Screen Bloom shader. So I'll just grab it right here in my project. and drag it right in. So we have our sample screen subgraph here, and I can just connect it. And there is the very beginning of our shader. So I'll hit save. And now the last thing that we need to do is add our test full screen bloom to our custom pass volume node. So here we are. This is the shader that is being used to render the bloom currently. So I'm going to come down here and find test full screen bloom and open it up. And there's a material in here. So I'm going to grab this material and drag it into the material slot. And now you can see that my bloom has gone away, and that's because I'm not actually doing any bloom yet in that brand new material that I just created, or that brand new shader that I just created. All I'm doing is sampling the screen, and here in my sample screen subgraph, I'm just using the screen's coordinates to sample the screen's color. So it's basically taking the screen and putting it back. So let's go ahead and expand on our screen sample subgraph so that we can use this sample multiple times to create our bloom. The first thing that I want to do is open up our blackboard and add some parameters here. First of all, we need a vector2 parameter called offset. And this is what we're going to use to offset the screen position that we're using. Then I'm going to create a float parameter called weight. And this is going to be the weight multiplier that we use to determine how bright this sample is going to be. Then I'm going to create another float parameter called LOD. And this is going to determine which MIP level of my HD scene color to sample. Can you see how I have an LOD input here on my HD scene color? Well, I'm going to use that parameter to determine which MIP level to sample. And the nice thing about this is if I'm sampling MIP 0, the highest resolution, the full screen version, it's nice and sharp. But as I go up to 1, 2, 3, or 4 on my LOD level or MIP level here, the blurrier my HD scene color is going to get. I'll show you what that looks like in just a minute. But let me add one more float parameter here. And this one I'm going to call cutoff. And this is what I'm using as the levels control, just like we did in Photoshop, where I slid the levels from left to right, and it made all of the darker pixels black. That's what this cutoff parameter is going to do. Okay, let's go ahead and drag all of our parameters into our subgraph here. And then I can go ahead and turn off my blackboard just to give me a little bit more room to work. So what I want to do for each sample that I'm doing is offset the sample slightly up or down or left or right so that I can get multiple samples and combine them like a filter kernel to create my final value. And so I need to take my offset value here and I need to multiply this offset value by the size of the pixels on the screen. And I can get the screen pixel size using this screen node here. You can see that I have the width and the height of the screen. And what I'm going to do is combine those together into a single vec2. And then I'm going to get the reciprocal of that vec2. So here's my combine node. Here's my red and green coming out of the combine node. And I'm just going to add a reciprocal node. And this is going to give me 1 over the screen width and height, which is the way that we calculate how big a pixel is on the screen. So if I take my offset value, let's say I have an offset of 1, 1, and I multiply it by the reciprocal of my screen width and height, what that's going to do is it's going to offset my sample exactly 1 pixel in screen space. And so that is the way that I can, sample 1 to the left or 2 to the left and get an offset that's exactly 1 pixel size. So once I have that offset, I can just add it to my screen position here. And then I can use this value as my coordinates to sample my screen buffer, my HD scene color here. Okay, with the shader the way that it is now, I'm able to go ahead and take samples and use this offset value to move the samples around so that I'm sampling different parts of the screen buffer here. The next thing that I want to do is control how much each individual sample is going to contribute to the whole. And with that, I can use this weight value. And this is pretty simple. All I have to do is multiply my sample here with the weight value and then pass the result out like that. Okay, the next thing that we want to do is take our LOD level and we can just pass that right into our HD scene color here. And that's going to determine, like I said, that's going to determine which of the MIP levels of our HD scene color we're sampling. Let's go ahead and take a look at what we've done so far and use some of these controls and see how things are working out. So I'm just going to save it here, and then we'll switch back to our test full screen bloom shader. Now you can see I have offset values, weights, LODs, and I have cutoff value. And so I need to add some numbers here to control exactly what this sample is doing. Let's go ahead and tear off this shader into its own window. And then we'll switch over to our scene so we can see what's happening. So now, if we take a look at our scene, we've got black. And we need to figure out why that is. The reason that's happening is because my weight value is defaulting to 0. And so it's taking that sample and multiplying it by 0, which is giving me black. So if I set my weight to 1, now I'll get my scene back. Now let's take a look at what we can do with offsetting. Let's just give this offset a value of 50 just for now. And now you can see that my sample is smearing here at the top and smearing over here on the right. And that's because it's shifted the place where the pixel is being sampled 50 pixels to the left and 50 pixels down. So let's go ahead and set that to 0. We can tell that our offset is working. Let's take a look at what our LOD value does. If I set it to 1, you can see that my scene gets a little bit blurrier. And the higher this LOD value goes, the blurrier my scene is going to get. If I go all the way up to 6, you can see that my scene is really blurry now. And the really nice thing about this is when I do bloom, I want the bloom to be kind of an overall haze. And I can use a lower LOD of the scene like this to get a blurrier image to sample for the bloom without having to do lots of additional samples. Okay, and the last parameter that we have here is cutoff, and we haven't actually hooked this one up. So let's switch back to our sample screen subgraph and go ahead and hook up our cutoff. All right, before we set up our cutoff value, there is one thing that I need to do to adjust what's happening with our LOD value. In order for this LOD value to work correctly, so what's happening when this LOD value increases is we're sampling an increasingly smaller resolution version of the HD scene color. And in order for our offsets to continue working correctly, we need to compensate for this because as we're sampling a lower resolution version of the HD scene color, the pixels themselves are getting larger and larger. And so we need to adjust the value of our offset relative to the value of our LOD so that we keep these offsets in the correct place for each of the pixels that we're sampling. So in order to do that, what we need to do is take this LOD value and raise 2 to the power of this LOD. So I'm going to add a constant value of 2 here, and we're going to raise that value of 2 to the power of this LOD value. And then we're going to multiply that value by our offset. And what's happening here is that as our pixels get larger and larger, our offset also gets further away so that the offset values are staying in their correct positions relative to the pixel size. All right, so we've got that little change created. And what this means is that we can adjust our LOD value up and down, and our offset values will stay in the correct positions. All right, cool. The last thing that we need to do is set up our cutoff value. Now, if you remember back to the beginning of the video, in Photoshop, I showed you that we are using the levels adjustment, and we're grabbing the little handle on the left side of the levels and sliding it in toward the middle to cut off the darkness values so that we only saw the brighter values. So what I'm going to show you here is the math that's being used for that levels. We're going to do that same kind of levels adjustment, but we're going to be doing it in real time to our screen instead of offline in Photoshop. So what I'm going to do here is I'm going to take my HD scene color coming out of here. We can add a subtract node, and we're going to subtract our cutoff value from that HD scene color value. And then we're going to saturate the result. And now I'm going to take 1 minus the cutoff value, so the inverse of that cutoff, and we're going to divide our scene color by that 1 minus value. So when we do a levels adjustment and we move around that little handle on the left-hand side, this is how that math is working. So the value that is generated by these nodes, I can then plug into my multiply and multiply it by our weight value. Now I'm just going to stick the weight value up here and rewire these into that multiply to organize things a little bit nicer. But like I said, these nodes here allow this cutoff value to act like that handle that we were using in Photoshop, so that as I take it from the far left in toward the middle, the darker pixels in our scene are cut off and the brighter pixels are left. So let's go ahead and save this, and I'll show you what I mean in the scene. So if we switch back to our test full screen bloom shader, you can see that I've got offsets of 0, a weight of 1, a LOD value of 6, and a cutoff value of 0. And if we take a look at our scene, you can see that because we're sampling that LOD value of 6, our screen is really blurry looking and low resolution. But our cutoff value is 0, so we're showing the brightness value of all of the pixels. And what we can do now is increase this cutoff value, say to something like 0.2, and wherever the darkest values are in the scene, it's going to make those go to black. And so it's just as if we're using that levels adjustment in Photoshop. So if I set this to something like 0.8, now we'll only be getting the brightest areas of the screen, and this is what we can use for the bloom. So the areas where we want to bloom, we can use that cutoff value to make everything else not bloom and only get the brightest areas to bloom. And then we'll add this back on top. Okay, well, let's keep going. What we can do is take this sample screen here with a weight of 1, with a LOD value of 0, and a cutoff value of 0. And this will just give us our scene itself with no bloom. But if we want to start adding bloom to this, what we can do is just take this and duplicate it 4 times. And this is going to be our first bloom kernel. So this is just going to be our standard scene here. And then our first bloom kernel here. And what we can do is just add these 4 values together. All right, and with 4 samples, what we want to do is put these samples, well, first let's go ahead and give each of these samples a weight of 0.25. Because if we give them a weight of 0.25 and add them all together, we'll get a total result of 1, which is what we want for the kernel. So we're basically multiplying each of these by 0.25 and then adding them together for a total overall value of 1. All right, now for this kernel with the 4 samples, we want to put these samples in the 4 corners of the pixel. So we're going to go with negative 0.5, 0.5 for one corner, negative 0.5, and negative 0.5 for another corner, 0.5, and negative 0.5, and then our last one is just 0.5, 0.5. So these are the 4 corners of our pixel. One of the cool things about putting these pixels into the corners is that because the pixels are blended together when they're sampled, if I have a sample right at the intersection where, at the corner where 4 pixels come together and I sample that value, I'm actually getting the blended value of all 4 of the pixels. And so each of these samples is actually getting the blended value of 4 pixels. So by doing 4 samples here, I'm blending 16 values together to get my final result, which is pretty cool. So if we wire this in, we can take a look at the result that we're getting from these 4 samples added together. And what we're going to see here is that the screen is just getting slightly softer. I might have to zoom in here in the video for you to be able to tell. But if we switch back and forth between our 4 sample version and our regular full screen version, what you're going to see is that the 1 sample version is nice and sharp, but this version where I'm doing 4 samples and averaging them together is just ever so slightly blurry. And that is exactly what we want for our bloom. This filter kernel that we've created with 4 samples is just doing a little bit of blur. All right, in order to control this a little bit, let's open up our blackboard here, and we want to add a couple of controls. What this kernel is the core of our bloom. So we're gonna make a bloom with 3 different stages. It's gonna have a core, a glow stage, and then a haze stage. So the core stage is gonna be nice and tight, not too blurry. And then the glow stage is gonna be a little bit more blurry. And then finally the haze stage is gonna be just really blurry, but also really subtle. So let's add a couple of controls into our blackboard here. We're going to add one control for the core LOD. We're going to add another control for the core cutoff value. And then finally, we'll add one last control for the core brightness. Now let's open up our graph inspector here. And for each of these blackboard values, we're going to go ahead and set some defaults and some controls. First of all, for each of these, I want to set our mode to slider so that when we edit our material, we can use a little nice slider UI element to control these. So I'm going to set each of these to a slider. Then for core LOD, we're going to default this one to 2. And we're going to set the minimum to 0 and the maximum to 8. For our cutoff value, our min and max is going to be 0 and 1. But we're going to default this to 0.8. And then for our brightness value, we're going to min and max this to 0 and 0.1. Because this is glow, our maximum is going to be fairly low. And our default value is going to be 0.05. All right, with those values set, let's go ahead and wire in our blackboard value. So I'll drag across our core LOD value and just go ahead and plug it into each of our LOD values here. And the same thing with our cutoff value. Just go ahead and connect it to the cutoff inputs of each of our sample screen nodes. And then for the core brightness value, I'm just going to bring it over here and tack it on at the end. We're just going to multiply our result by this core brightness value. And then if we plug this into our output shader, now what I need to do, since I have these blackboard values, these exposed parameters, I need to go ahead and create a material that I can use to tweak this in my scene. So I'm going to right click in my project window and pick Create Material. And I'm going to call this material Test Full Screen Bloom. And then we need to come up here to the material properties and I need to assign my shader to it. So for my shader, I'm going to pick the Test Full Screen Bloom shader. Now I can grab this material and I can apply it to the screen. So I'm going to pick my custom pass volume here and come over here to my passes. And I'm going to go ahead and take my Test Full Screen Bloom material and drop it into that material slot there. Okay, now that I have that material assigned to the screen, if I select the material here in my project, now you can see these properties that I've exposed in the material. I have my core LOD value, I have my core cutoff value, and I have my core brightness value. So if I adjust my core LOD value, you can see that it's controlling how much blur is applied to this bloom. And I think for this one, I'll set this value to 1, but you can see what it does. The higher that LOD value gets, the lower of a LOD I'm sampling. So we're going to sample LOD 1 in this case. For our cutoff value, the lower this value gets, the more of the pixels we see. But then the higher it gets, the more we're cutting off those values and sampling them to black. So what I'm going to do is set this value to 0.8. And then finally for brightness, we can adjust this and you can see that it's getting brighter or darker. So for this one, I'm going to leave it at 0.05. All right, now that we have these values that I can tweak, we'll come back here to our Test Full Screen Bloom shader, and we'll go ahead and add in our regular full screen sample. So I'm just going to create an add node here and wire this part of our bloom shader together with the regular screen sample so that they're getting added together. And then we'll take a look at our final result. Okay, so here is our standard screen rendering together with our bloom value. Now, if I take my core brightness and just turn it all the way down, I get no bloom at all. But if I turn this up, you can see how I'm adjusting the brightness here, especially visible here on the leaves. As I adjust my brightness, you can see that bloom here, but also maybe right here around the edges of the sunny patch on the floor. If you take a look right there, as I'm adjusting the brightness, you can see that bloom kind of spilling out and overflowing beyond the bounds of where it normally would be. So I'm just going to go ahead and set this to 0.05. And that is the first portion of our bloom. So this is what we're calling the core. All right, for the next portion, let's switch back here to our Test Full Screen shader. And we're going to add another series of screen samples. This time we're going to add 7 of them. And this is what we're going to call the glow portion of our bloom filter. So I'm just going to copy these 4 samples here. And then we'll copy them again. We just want a total of 7 samples. And we want all of them added together. All right, perfect. Now, this set of samples is going to be similar to the filter kernel that we created when we were doing our blur. Basically what this one's doing is we want one sample that's right in the center, and then the other 6 samples are going to be in a hexagonal pattern, kind of around in a circle around that center pixel. So in order to do that, we need to set these offset values to 2 and 0, and then -2 and 0. And so those are the two, the right and left sides of the hexagon. And then the other 4 samples here are going to be the upper and lower corners of the hexagon. So we'll set this one to 1 and 2, 1 and -2, -1 and 2, and then -1 and -2. So there we've created like a circular hexagon shape with one point in the middle there. So now for the weights. What we want to do with our weights here is set this to 0.3 for the sample in the middle. And then we need to divide the remaining 0, because we want these weights to add up to 1. We basically have 0.7 left after 0.3. So we want to divide that by 6. And when we do that math, we end up with a value of 0.11667. So I'm going to go ahead and paste that value into the weights of our remaining 6 samples. All right, so we've got our offsets and our weights. Now we just need to add some Blackboard elements for our LOD value, cutoff, and brightness. And for this, I think I can just copy and paste the ones that we created before and rename these. So I'm going to create a glow LOD, a glow cutoff, and a glow brightness. Then we'll open up the graph inspector here, and I'm just going to set the default values for each of these. So for a default glow LOD, we're going to set this to LOD 5. For a default cutoff, I'm going to set this to 0.6. And then for a glow brightness, we're going to leave this at 0.05. Great, so let's go ahead and wire up these values. So our glow LOD is going to plug into each of the LOD sockets of my 7 samples. And then the same thing with my glow cutoff value. I'm just going to wire that into each of the cutoff values of my 7 samples. Perfect, and then finally for our brightness, we can just take our brightness value and multiply it by our final result. Okay, so now I can take my glow kernel and I can add it together with my core kernel and my screen to get our final result. So I'm going to take this and hit and create an add. So we're going to add that together with our core kernel, and then we're going to add that together with the rest of our screen. And we'll hit save and switch back to our scene and take a look at what we're getting. Okay, so in our scene, if we come down here and select the material that we created, you can see that now I have some additional parameters that I've exposed. So here's my core value. And just for now, I'm going to set my brightness of the core down to 0. And here is the brightness of my glow. So with glow, you can see that I can adjust the size of the blur that's happening there, or which LOD is being sampled. And we've set the default to 5, so it's pretty blurry. If I adjust my brightness, you can see how much that glow can contribute to the blooming effect. And if I turn it way up and also turn the cutoff down, you can see that more of the scene is contributing. If I turn it all the way up, we're only getting the brightest pixels contributing. Then if I turn my brightness down, so you can kind of get a feel for what these controls are doing. This controls the overall brightness, and then this controls which pixels are contributing, and then this controls like how tight, how sharp, or blurry spread out the effect is. So pretty cool. Let's set these back to the values where we had them. We're going to set it to 5 and 0.6 and brightness of 0.5. 0.05. Okay, so we've got our core effect, and we'll set its brightness back to 0.05 as well. You can see if I play with that, what it's doing. So we've got our core effect and our glow effect, and we're going to add one more, which is our haze effect. And this is just going to be a general bloom all over the screen, and we're going to keep it kind of subtle so it's not too strong. So let's switch back to our full screen effect again. And this one's pretty easy. We're just going to use this same 7 sample filter kernel again. So I can just take these nodes and copy and paste them. And I can use the same offset and weight values. And so that means for this final haze kernel, all I need to do is set the LOD and the cutoff, which those values need to come from these exposed Blackboard parameters. So I'm going to copy this glow LOD value and rename it to haze LOD. I'm going to copy my glow cutoff value and rename it to haze cutoff. And then I'm going to copy my glow brightness value and rename it to haze brightness. Okay, and then I can drag these parameters into the scene and wire them into their corresponding sockets. And then finally, I'm going to multiply the effect by my haze brightness value so I can use this value to tune how much of that haze I want to contribute. Then I can add my haze into the chain here. And then the last thing that I want to do is tune these parameters that I've exposed here, so they're just so they're different from the core parameters and the glow parameters. So I'll open up my graph inspector. I'm going to set my default LOD value to 7, my cutoff value to 0, and I think we'll keep our haze brightness at 0.05. Okay, and then for the last thing, just for a nice final touch, I'm going to add categories here. And this one I'm going to call haze. I'll add another category and call it glow. And a last category and call it core. And then I'm going to move these parameters into the categories. Just to keep things nice and clean and organized. All right, so I've got a core category here, a glow category, and a haze category. And if we save this and switch back to our scene, now you can see that when I'm editing the materials, I have these nice separations between the parameters. So it's really easy to see these are the parameters that go with core, parameters that go with glow, and the parameters that go with haze. Okay, so now I can go ahead and tweak these to my heart's content. You can see that my haze is contributing to the overall scene. I can also control how tight or blurry my haze is. And then the same thing with my other values. I can tweak the brightness of these, each of them independently, to control how much they contribute to the effect. So I've got my core effect, which is just really tight around the brightest areas in the scene. I have my glow effect, which is cutting off at 0.6, so it adds some nice bloom to the areas that are brighter than 0.5. And then I have my haze effect, which is contributing to the scene overall, so I can control how hazy or how clear the whole scene is. So pretty cool. I've created this post-process bloom effect, and it's working really great here in Unity. Just as a last touch, I'm just going to fly around the scene here a little bit so you can get an idea for what our bloom effect is doing. You can see that it's adding some nice additional bloom and haze to our bright lights up here. I kind of swing around here. Ooh, this is nice. So we're looking into that bright room over there, and you can see that that brightness is kind of spilling out into the surrounding areas. I really like that effect. And if we come over here to our metal ball, you can see that this highlight here outside is kind of blooming here, and that sun glinting off of the ball is so bright that it's kind of spilling out into the scene. And these are all things that we can tune using our material parameters here in our material. Okay, cool. So that's how you can create a bloom and glow effect in Unity. Now I'm going to switch over to Unreal, and I will warn you kind of right off the bat that I was unable to create this same effect in Unreal. And I'll show you why, and I'm hoping that some of you can maybe show me how to fix this and maybe add some comments down below to show me how to fix this problem. Okay, so let's switch over and I'll show you my progress so far. All right, here we are in Unreal, and you can see that I've created a material function for myself, just like I did in Unity, where I'm able to give it an offset, a LOD, a cutoff value, and a weight. And so I've set up these nodes to do exactly like the Unreal version did. So first of all, we set up the offset coordinates, and then we use those to offset our texture coordinates. And then we sample our scene value, and then we apply our cutoff values so that values darker than that go to black. And then we multiply by our weight. However, the problem that I'm running into is there's no way to tell the engine to sample our scene pixel at a lower LOD or a lower MIP level. And so my only option here is to sample the screen at full resolution. And this doesn't work so well because what I'm trying to do is blur the screen, and that's much harder to do when I have to sample the full resolution. I need to take like significantly more samples if I want that to work right. And I'll show you the results in just a minute. But here is the overall shader. You can see that I've got the scene, and then I've got my core filter kernel, I have my glow filter kernel, and I have my haze filter kernel, just like I set up in Unity, and have all the values set up the same as well. Although right now I have my weights turned up to 1 for each of these, just so when you look at the results you can see exactly what's happening. If we switch over to the scene, you can see that each of my samples is actually visible. This is kind of an interesting look. And the reason that I'm not getting the blurring is because I'm not able to sample those lower MIP levels, and so it's sampling the full resolution screen texture instead of a lower MIP of that screen texture. So when I'm sampling my scene, I need to find a way to be able to sample a lower resolution or pre-blurred version of the scene, and I don't know how to do that. So if that's something that you have experience with, boy, let me know how to do that down in the comments. I'd really appreciate it. If I do find a solution to that for next week, I will go ahead and create a full video explaining how to do this process in Unreal. But if not, I think we're just going to have to move on, and I'll proceed to our next step in Unity. Okay, so finally, what we're going to do next week is take the bloom that we did today, combined with the radial blur that we did in our previous episode, and when we put those two together, we're going to get God rays, or sometimes referred to as crepuscular rays. So be sure to come back next week for that tutorial. And until then, have a great week, everybody.